Hey kiddos. The other day we looked at land biomes and how Earth's land biomes differed, how they were different, the various, what desert, grassland, tropical rainforest, temperate rainforest, temperate deciduous forest, taiga, and tundra. All right, and we looked at how humans impact those land biomes. Okay, today what we're doing is we'll move on. We're going to look at aquatic ecosystems in land biomes, and we're going to look at the different aquatic ecosystems and how humans impact those systems. Okay, there are four major types of ecosystems, aquatic ecosystems: freshwater, which includes streams, rivers, ponds, and lakes; wetlands, estuaries, and ocean, which includes open ocean, coastal oceans, and coral reefs. Okay, some important abiotic factors that deal with aquatic ecosystems include, but are not limited to, temperature, sunlight, dissolved oxygen gas, which is the oxygen that's in the water, and salinity, which is the amount of salt that's dissolved in the water. All right, and a little something to know is that all aquatic species have adaptations which enable them to use the oxygen in the water, like the gills of a fish, or allow them to take in the water and filter out the oxygen from the water. All right, first look at freshwater streams and rivers. Streams are usually narrow, shallow, and very fast flowing, okay? They form from underground sources of water, like a spring will come up, and that's how streams form. They're often clear because the soil particles, or the dirt, the minerals, nutrients, and stuff, it's moving so fast that it's all washed downstream. It doesn't have time to collect and make the water murky. Oxygen levels are high because the air mixes easily as water splashes over the rocks. Okay? Rivers are larger, deeper, and flow more slowly. All right? They form when a bunch of streams come together. The soil that washes downstream from those streams, wash into the rivers, and since they're moving slower, it has time for that dirt, soil, nutrients, and everything to kind of make the water murky. So you can have kind of muddy-looking rivers. The water looks kind of sort of muddy, murky. They do have high levels of nutrients because all the minerals and whatnot are washed downstream into the rivers, but lower levels of oxygen because they're not moving as fast, so that not as much oxygen is getting churned up into the water. There's, of course, biodiversity is crazy. There's so many different organisms, plants, animals, species, etc., in rivers and streams. And like I said, this is not a list of everything, but it kind of gives you an idea of what lives in and around these ecosystems. Water-loving plants like willows and cottonwoods. You'll find in streams fast-moving water species like trout, salmon, crayfish or crawfish, and a lot of insects. Slow-moving water species, snails, catfish. The human impact, well, I mean, my goodness, we take water from streams and rivers for drinking, laundry, bathing, crop irrigation, industrial purposes. Hydroelectric plants, remember, hydro, water. You got hydroelectric, hydration, dealing with water. Use energy from the flowing water. The dams stop up the water's flow for hydroelectric plants. And runoff, this should be from cities, industries, and farms, is a source of pollution. So, it all runoff, and what I'm talking about with runoff, we have fertilizers when we plant crops. The farmers fertilize their crops. When we have gardens and whatnot, you put pesticides and everything on your flowers, or at least your parents, grandparents do and stuff. And when it rains, those pesticides and those fertilizers and stuff like that, and just normal, average, everyday things, like think of all the stuff that you wash down the sink, your soaps, and washing your hands, or the shampoos and conditioners and all of that. That runoff, a lot of that will get into the water system and get into our streams and rivers, and can be a source of pollution. Okay. Ponds and lakes contain fresh water that's not flowing. Now, there may be currents in lakes and ponds and whatnot, but it's all contained, within that pond or lake. It's not flowing, continuously flowing from one place to another. It's contained within that lake. They usually form in low areas. Ponds are shallow and warm. The sunlight reaches the bottom. and the water is high in nutrients. Lakes are larger and deeper than ponds, and the sunlight reaches the top few feet, but then the deeper you get, the colder and darker the water gets. Um, uh, Lots of plants surround ponds and lake shores. Surface water contains plants, algae, microscopic organisms that use sunlight for photosynthesis. You'll find cattails, reeds, insects, frogs, crayfish or crawfish, perch, trout, bass, walleye, all sorts of things there. Human impact. Lots of time when we need more land, we'll fill in ponds and lakes to create land for houses, other buildings, except roads, whatever. Once again, runoff from farms, gardens, and roads washes pollutants into the ponds and lakes and can disrupt food webs. Wetlands are aquatic ecosystems that have a thin layer of water covering the soil that is wet most of the time. Okay, you can have freshwater wetlands, saltwater wetlands, or both, a mixture of both. Wetlands are among the Earth's most fertile ecosystems. They form on the edges of lakes, ponds, and in low areas of land, also along ocean coasts. They've got high levels of nutrients and they're very biodiverse. Wetlands are great. They trap sediments and help to purify water. The plants and microscopic organisms that live in wetlands help to filter out pollution and waste material, so help clean the water. You're going to get cattails and grasses. Very few trees grow in saltwater wetlands. So if you see trees in wetlands, there's probably going to be freshwater wetlands. But you're going to see cottonwoods, willows, swamp oaks. Insects are abundant. Of course, anytime you get water and warmth, you're going to get insects. More than a third of North American bird species use wetlands for nesting and feeding, which is, that's a lot. That's a lot. Human impact in the past, water has been drained from these areas, and homes and roads and farmland have been built there. Of course, today most wetlands or many wetlands are being preserved, and a lot are being restored. They're being brought back to their natural state. All right, estuaries, regions along coastlines where streams or rivers flow into a body of salt water. So you get the mix of freshwater, saltwater, all right? And the salinity depends on the rainfall and how much fresh water is entering into the salt water, the ocean. How big the river stream is, how much fresh water is coming into it. Estuaries help protect coastal lands from flooding and erosion. They help to purify water and filter out pollution. They've got very high nutrient levels and a lot of biodiversity. You're going to see mangroves, pickleweeds, seagrasses. You're going to see worms, snails, oysters, shrimp, just all sorts of species, life there in estuaries. In the past, large portions of estuaries have been filled in for homes, roads, and buildings, just like with wetlands. And the destruction of these habitats, have been detrimental to the species that live there, and also to the coastlines and to our land, because those estuaries they were kind of a barrier, a protective barrier between storms and flooding. And without them, the flooding and storm damage comes into the actual land that we build our houses on and everything. So, open oceans. All right, most of the Earth's surface is covered by ocean water with high salinity, salt water. The open ocean extends from the steep edges of continental shelves to the deepest parts of the ocean. If you see up here, I don't know if you can see my little cursor there, but you see the coastal, the continental shelf, and you've got your intertidal zone, your coastal zone, and then you've got your open ocean. It's everything else, right? So it covers a lot, All right, photosynthesis takes place only in the most the sunlit zone, the uppermost zone of the ocean, the first 200 meters of the ocean here. And that's where you're going to get all your algae and stuff that use sunlight and photosynthesis, okay? Very little sunlight reaches the twilight zone and the dark zone, which is, the middle part of the ocean and the very deepest water, the deepest part of the ocean. Of course, the ocean is very biodiverse. There's so much life there. You know, algae, jellyfish, all the way to sharks and whales and, you know, sea cucumbers, dolphins, whatever. And human impact with oceans is, of course, overfishing. You know, taking so much fish out, particularly one species of fish that, you know, near to extinction. We bring them near to extinction. Trash discarded from vessels, ships, and whatnot, and also washed into oceans from land. From land is a source of pollution. And the thing is, a lot of the animals, sea animals, can become tangled in this trash or mistake it for food and eat it. And then they've got a lot of plastic in their belly and they end up dying because they can't digest it. Coastal oceans include continental shelves and intertidal zones. An intertidal zone is the ocean shore between the lowest low tide and the highest high tide, kind of the beachy part of the beach that you play on. You know, like if you go and that the tide, the surf comes into, okay? Sunlight reaches the bottom of coastal ecosystems. Nutrients are washed in from rivers. It contributes to high biodiversity. It's home to mussels, fish, crabs, sea stars, dolphins, whales, all sorts of life in this area, coastal ocean between the continental shelf and the intertidal zones. The human impact, oil spills, and other pollution can harm these coastal organisms. You know, if there's an oil spill or just trash, like I said, they can eat the trash, think it's food, and can get sick and die. Coral reefs. It's an underwater structure made from outside skeletons of tiny, soft-bodied animals called coral. Okay, usually form in shallow tropical oceans. Coral reefs help protect coastlines from storm damage and erosion. They're got a lot of biodiversity because you've got all these various kinds of coral, but you also have, I mean, there's just so much life that lives in and around coral reefs. Okay, it provides food and shelter for so many animals, sea animals, parrotfish, groupers, angelfish, eels, shrimp. I mean, it goes on and on and on. Because then not only are they eating the coral or the little microorganisms that are around the coral, then you got the bigger things like sharks and whatnot that come to eat those fish. So I mean, it's just a huge. It's kind of like Grand Central Station of the ocean. Coral reefs are. Everybody's going to come there. Or like the kitchen, you know, everything shows up in the kitchen. Everybody shows up in the kitchen. That's sort of like the coral reef. Human impact, pollution, overfishing, and harvesting of coral threaten coral reefs. Also tourism, you know, everybody wants to go and snorkel and swim around the coral reefs, but touching them and messing with them can kill them. And so, you know, that's why there's a big movement. If you do go and swim around coral reefs or scuba dive around coral reefs, there's a big, a big no-no to touch them or to mess with any of them or to take anything from them. You just swim and observe. All right, watch this little video. It gives a good overall view of aquatic biomes. Okay, so we've looked at Earth's aquatic ecosystems, how they're different, and how humans have impacted those ecosystems. Okay, we're also going to look at how our ecosystems change over time. Okay, how land and aquatic ecosystems change over time. All right. Land ecosystems, ecological succession is a process of one ecological community gradually changing into another. Okay, kind of like, okay, so we concrete over, you know, we put concrete over, we make a sidewalk over the dirt and over plants and everything, which kills them. Okay, well, eventually cracks start to appear in the sidewalk and little weeds start to grow up in the cracks, and if they're not taken care of, those weeds will eventually become bigger and crack the sidewalk more. And eventually there'll be more plants that grow up in the sidewalk and crack it up and break up the sidewalk more to where shrubs and vines can grow in there. And they break it up even more to where eventually trees will grow and the sidewalk will kind of be taken over with vegetation, and there's no more sidewalk. There's a whole new little ecosystem there of plants. Okay. The final stage of ecological succession is called a climax community. Okay, and it's a stable community that no longer goes through major ecological changes. Once it's there, it's kind of there. Things will die, but the same type of plant will grow in its place. Okay, and these are usually stable for hundreds of years. Like, let's think about if farmland, farmer plows it up and everything. Well, if he quits using that piece of land to farm, to grow crops on, and just lets it go, doesn't plow it up, doesn't plant anything on it. Eventually, the native grasses and bushes and trees will grow back on that land. And once it's kind of fully consumed, it's all taken over and back to its original state. That's called a climax community. And it'll stay there. Plants will die, but new plants, the same type of plant, grasses and trees and whatnot, will grow in their places. That's the climax community. Here you got a little diagram of kind of how it'll change, or how it'll grow over time. Oh wait, I put that wrong. Shoot. I'm sorry. This is talking about primary and secondary succession. I don't know what I did, but anyway, it kind of shows, we're fixing to get into primary and secondary succession, how the stages in which plants overtake, or ecological succession, how they overtake an area, or how they grow in kind of their stages. You got the smallest that grow first all the way to the biggest. Okay. Primary succession is ecological succession in new areas of land, okay, with little or no soil, such as on a lava flow, sand dune, or exposed rock. Okay, what happens is, like, let's say a volcano erupts and you've got all this lava that flows into the ocean and makes new land, builds up new land. There's nothing on there. Nothing has ever grown there. The lava dries into this, rock, okay? Well, eventually lichen and mosses will start growing there. Okay, and they help to break down that lava rock into bits of dirt and gravel and soil. Okay, make it in soil. And after the lichen and mosses grow, then you get smaller, ferns and smaller plants that start to grow there. Okay. And then once those smaller plants grow, then you get shrubs, you get bigger plants, and it's just a progression to where eventually you get trees and you've got a full-grown ecosystem going on this brand new, rock that nothing's ever grown on, and that is primary succession. Pioneer species are those first species that colonize that undisturbed, that brand new rock, okay, like lichen and mosses are examples of pioneer species. Okay. Secondary succession occurs when there was an existing ecosystem there. Like I said, like the farmer plows up the field, okay, and grows crops. Well, there had been an ecosystem there, right? There had been a forest there, and he clear cutted the forest and plowed it up, so there was a crop ecosystem there, and then he let it go and just let everything grow back. So a secondary succession came in when that forest took back that land. Okay, or like if there was a fire that destroyed a forest area or destroyed an area, and then eventually, plants and stuff will take back over that area and grow back where it was. That's secondary succession. So you got primary succession on brand new rock or soil that's nothing's ever lived on before, and secondary occurs where there's been something before, but for whatever reason it was disturbed or destroyed, fire, whatever, and new plants and whatnot have grown back over it to take it back over. All right, freshwater ecosystems. Aquatic succession is when freshwater ecosystems change over time in a natural, predictable process, okay? And it begins with a body of water like a pond, all right? You've got a pond. Well, over time, sediments and whatnot, more dirt gets into the pond. Things die, and when, like, fish die, they'll sink to the bottom of the pond. Well, and decompose. Well, it doesn't just disappear. Those remains don't just disappear. They transition into carbon, dirt, soil, other things, and so it builds up layer upon layer in that pond, and that pond eventually becomes more shallow and more shallow because that dirt and sediment builds up in that pond. Okay, and eventually the pond fills up completely with soil, sediment, and so a land ecosystem develops. There's no more water. There's not a dip, there's not a hole that water can fill up in. It's all land, flat land that a land ecosystem will come and take over. Okay. Now, eutrophication in dealing with aquatic succession. Like I said, that fish will die or whatever, dead, decaying organisms fall to the bottom of the pond and add nutrients to the water. Okay, well some of it, some of that dead, decaying organism goes back into kind of the sediment. All right, the soil, but some of it are nutrients and they're released into the water. Okay. And eutrophication, big word, is the process of a water becoming nutrient rich. You want water to have nutrients in it, but at some point there can be too many nutrients. Have you ever heard, that's why your parents only let you eat 1 or 2 Flintstone vitamins, because too many vitamins can be dangerous. If you can have too many nutrients, too many vitamins, and that can be dangerous. But you want so much, a little is good, a lot is not great. Okay, but eutrophication is natural. It's a part of the natural aquatic succession. Okay, because the more things die, the more nutrients that are in the water, or the more things die, the more nutrients are going to be put into the water. Okay, and the more nutrients in the water, you're going to get the more microscopic organisms and algae that eat those nutrients. Well, they take oxygen too. Okay, and so the more algae and microscopic organisms are there, the more oxygen they use, the less oxygen there is for fish and other organisms to breathe and to survive with. So that is eutrophication. Now, the human problem, or the human aspect of this eutrophication, is that we a lot of times help speed this process up, which is not necessarily a good thing. It should be in a natural progression. But fertilizers, pesticides, stuff like that have nutrients in them. Okay, and so when you get that runoff from farms and stuff, and all that runoff is going into ponds and rivers and lakes and everything, well, those nutrients are being put into those ponds, and so it can speed up that eutrophication process. All right, and kill off a lot of pond life, species of aquatic life in that pond, lake, whatever. Okay. All right. This is a great little video talking about ecological succession, so watch it. They're not long. You can do it for 6 minutes, I promise you. Okay. So we've looked at how land how aquatic. No, I'm sorry. I'm getting confused. We did look at how land ecosystems change with primary and secondary succession, and we looked at how aquatic ecosystems change with aquatic succession and eutrophication. Okay, so look, tomorrow we're going to review. There will be a Kahoot posted. We will review for our test on Monday. You've got all the notes. If you've got any questions, shoot me an email or ask me, in class, and that's it. See y'all later.